Hello students, welcome to our series where we are going to solve previous year questions of various categories. Today we are solving JEE Mains 2025 questions of electrostatics. So I strongly recommend that you first finish off all the theory videos where we have taught all the concepts, and now if you are done with that, then you should always test your knowledge by doing the previous year questions. And once you're done with that also, now go for the video solution. So without wasting any time, let's get started. What are we doing today? We are doing JEE Mains Electrostatics January 2025 questions. Put down that heading. Alright, so the first question is from 29 January shift 2 attempt. A point charge causes an electric flux of -2 into 10 raised to the power 4 Newton meter square per coulomb to pass through a spherical Gaussian surface of 8 centimeter radius centered on the charge. The value of the point charge is, okay, so can't get easier than this. This is a Gaussian spherical surface and there is a charge centered at the sphere. Okay, the flux is given to be a negative of this much. So students, I hope you know this, that if it is a negative flux, that means the field lines are entering into the surface, and this radius is just given to us to just confuse us, because we don't need the radius to calculate the flux. If we have the charge and it's a closed surface, we will straight away write Gauss theorem that it is equal to the net charge enclosed divided by epsilon naught. Now the charge enclosed is of course going to be phi into epsilon naught, and the value of phi is like -2 into 10 raised to the power 4. Epsilon naught of course you know is 8.85 into 10 raised to the power -12. So solving this becomes -17 into 10 raised to the power -8, like 17.7 to be precise. So the correct answer is option D, my dear students, right? So easy, right? So you just had to use Gauss theorem that flux is equals to the charge enclosed divided by epsilon naught, and we obviously would have rejected option A and B because there the charges are given as positive, which is not true. If the flux is negative, the charge also needs to be negative, right students? Copy this down, then we move forward. Alright students, so the next question is from 29 January shift 2. An electric dipole is placed at a distance of 2 centimeter from an infinite plane sheet. Nothing mentioned whether it's conducting or not, so we will take it as a non-conducting sheet and having surface charge density sigma naught. So we do understand that electric field is going to be sigma by 2 epsilon naught, and it is going to be a uniform field. So it is a uniform field directed towards the right, and now we have placed a dipole at a distance of 2 centimeter. The direction of dipole moment in physics is always from negative to positive, so it is also towards the right, my dear students. Okay, so now let's write the expression for torque. Of course you know that it's P cross E, so that is like PE sine theta, while the potential energy is minus P dot E, that is minus PE cos theta. Now if theta is 0, let's take down the values. If theta is 0, then the torque is 0 and potential energy is minimum, that is equals to minus PE. And what about the force, my dear students? So force is basically going to be 0. Why? Because whatever force positive Q would experience to the right will be balanced off by the force negative Q will experience towards the left, right? So I hope you know all these concepts. Now let's look at the options. First option, potential energy and torque both are maximum. That's not true, students. Both are not maximum, in fact. So this is absolutely false. Torque on dipole is 0 and the net force is directed. Torque is 0, all right, but the force is not directed away from the sheet. In fact, the force is 0 itself. So torque on dipole is 0 and the net force acts towards the sheet. So again, yes, this could have been true if this would have been a line charge. If it would have been a line charge, then this attractive force would have been greater than the repulsive force. In that case, option C would have been correct. Let's discuss that also. But right now it's not true because these two forces will eventually cancel out each other because it is a uniform field. For a line charge, it is a non-uniform field, and in that case the answer could have been C. But right now the only choice left is D. Potential energy is minimum and the torque is 0, which is very much the case here. So I hope you got it right, and the answer should be option D. Right students, so I hope you've tried the questions yourself first. Now this is from 29 January shift 1. An electric dipole of mass m and charge q and length L is placed in a uniform electric field when the dipole is rotated slightly from its equilibrium position and released, the time period of its oscillation is. Alright students, so there is an electric field, let's say towards the right, and we have placed a dipole, let's say minus q and plus q at an angle theta. Right students, so we do understand that, let's say if this experiences a force QE to the right, this will experience a force QE to the left, eventually causing a torque, and the value of torque we do understand is like PE sine theta. But this is not going to be SHM, of course it's going to be oscillation. Once you release it here, it will try to align along the field, but due to inertia it will go further and it will start oscillating like this. So it will oscillate, but it won't be SHM. But if we assume that theta is very small, which is given in this question, then we can approximately write it as PE theta. Now if it is PE theta, we can equate this to I omega square theta, because this is the restoring torque. Just like in SHM, if the restoring force is m omega square x, so restoring torque, instead of m, now we have moment of inertia, instead of x we have theta. So the value of theta here cancels out and we have PE by I, my dear students, that's omega. So the time period is going to be 2 pi by omega, so it's going to be 2 pi I over PE. Now what about I? So we are assuming that both the masses are m each, though it's not very clear, but they have just written an electric dipole of mass m and charge q, which could have also been meant that, you know, the combined mass is m. But if we do that, none of the options matches, and hence we will assume that masses of each particle is m, and hence the moment of inertia, I'll calculate it separately, will be ml by 2 whole square plus ml by 2 whole square, for obvious reasons, because we are writing moment of inertia from the center, and from the center we will assume that both the charges are at a distance L by 2. So the moment of inertia will turn out to be ml square by 4 plus ml square by 4, that is going to be ml square by 2. So the time period is going to be 2 pi, and instead of I will write ml square by 2, and P would be Q into L, and this is like E or E naught, whatever they are calling it. So the time period turns out to be 2 pi under root of ml by 2 Q E naught, which is correct option D, my dear students. Very easy, nothing which can create a problem here. If you know the concepts, then it's a very easy question. Right, still copy this down and then we move to the next one. Right students, so the next question is from 29 January shift 1, and we have various configurations here, and we have the electric field strengths here. Okay, so electric field inside of a uniformly charged spherical shell. So it's a uniformly charged spherical shell, then we do understand that electric field at inside point is going to be 0, of course, right? So electric field is 0, so with option A we will definitely match option 3. Let's check which one is matching A with 3, and we'll discard the other options. So A is matching with 3 in first, and in fact it's not matching in any of the other options. That means the correct answer is A. Of course we know the answer right away, but still let's just cross check all the other options as well. Now B, electric field at a distance r greater than 0 from a uniformly charged infinite sheet. We have just talked about that. So electric field is sigma over 2 epsilon naught, my dear students. So the correct answer with B is going to be 2, is going to be the perfect match, which is in option A. Now third, C option, electric field outside a uniformly charged spherical shell. So we do understand outside it is kq by r square, and if we can write k as 1 over 4 pi epsilon naught, and instead of q we will write sigma into 4 pi r square divided by r square. So this 4 pi term will cancel out, and this will become sigma r square over epsilon naught r square. So the correct answer is going to be option 4, my dear students. Right, so C matches with 4, which is in option A. Okay, electric field between two positive and equal and opposite charge plates. So it's like plus sigma and minus sigma. So electric field is going to be sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that is sigma by epsilon naught. So the correct answer for option D is going to be option 1. Hence all the 4 options are correctly matching. You can write anything if you want, and then we move to the next one. Alright students, so the next question is from 28 January shift 2. An electric dipole of this much dipole moment is placed in a field, uniform field, Initially, the dipole moment is parallel to the field. The work that needs to be done to make it opposite to the field can't get easier than this. Theta initial is at 0 degree, that is P and E are in same direction, while theta final becomes 180, that is P and E becomes opposite, right? So in fact we have rearranged the direction of E of P. So P is made opposite now while E is still the same. Whatever it is, initial potential energy we can calculate, final we can calculate, and whatever change we've brought is because of the work done. So work done is going to be U final minus U initial. So it's going to be minus PE cos theta final minus cos theta initial. So that's going to be minus PE, and cos 180 is going to be minus 1 and cos 0 is going to be 1. So it's going to be 2 PE. Very easy, students. Let's just plug in the values. The value of P is 6 into 10 raised to the power minus 6, and the value of E is like 10 raised to the power plus 6. So this becomes 12 joule, my dear students, right? Copy this down, very easy. Then we move to the next one. Right, students? So this was a numerical type, and therefore we have to put the answer as 12. 3 infinite, okay, so this is 28 January shift 1. 3 infinite long wires with linear charge density are placed at along x, y and z axis respectively. Which of the following denotes an equipotential surface? Okay, so we have to find the locus of equipotential surface. So for that, let's first revise that electric field due to a line charge having linear charge density is E is equals to 2k lambda by r. Now V is equals to minus integration of E dot dr, right? So what are we doing here? We are first calculating V using E. So V is nothing but negative of line integral of electric field. So when we do that, minus 2k lambda is constant and 1 over r integration we are left with. So that's going to be ln r, right? And let's put in a constant of integration because we're not putting the limits. So it's going to be like this. We don't care about the limits. We are only talking about the absolute potential. We will add them and we will talk about having equal potential. So that is what equipotential surface is. But now let's imagine that there is a line charge along the x-axis, and if it is along x-axis and there is any point whose coordinate we write general coordinate x, y, z, then the perpendicular distance is what we bother about, is going to be under root of y square plus z square, because the wire itself is along x-axis. So moving along x-axis won't take the point away from the wire, and it will only be the y and z coordinate which will decide the perpendicular distance, my dear students. Similarly, for the wire along y, it would be under root of x square plus z square. Similarly, the wire along z, it would be under root of x square plus y square. So what are we going to do? We are going to write V1 plus V2 plus V3 is equals to constant, and hence it is going to be minus 2k lambda ln under root of y square plus z square for the first wire, then again minus 2k lambda ln under root of x square plus z square for the wire along y axis, and minus 2k lambda ln under root of x square plus y square for the wire along z axis. So this 2 can be taken as power of this, and hence square root and square will cancel out, and then we can write ln y square plus z square plus ln x square plus z square plus ln x square plus y square is equal to some new constant, right? And this is now log a plus log b plus log c, so which is going to be ln y square plus z square. So we will just multiply the terms, because we do understand log a plus log b plus log c is log a into b into c. One more thing, even the NEET students can attempt these questions. These are very much relevant for them as well. Okay, so JEE Mains, since there are so many questions in every attempt, you can always take it as a good question bank even if you're a NEET aspirant, right? So the correct answer here is the term that we need constant to be is this much for it to be an equipotential surface, right students? Copy this down, then we move forward. All right, so the next one. Okay, so this is from 28 January shift 1. A particle of mass m and charge q is fastened to one end of a massless string having equilibrium length L, whose other end is fixed to point O. We can clearly see it. The whole system is on a frictionless horizontal table, so there is no role of gravity, and a uniform electric field is switched on in the direction shown. Then the speed of the particle when it crosses the x-axis. So this electric field is going to push the particle, but since it is bound to move like this along the circular arc, and that's because this is fastened here, this point is fixed, so it is going to move in a circular arc. So this length is going to be L as well. Okay, and this particle like has moved how much distance? It has moved L by 2 distance to the right. Why? Because why do we bother about the right? Because ultimately I can clearly understand that we have to talk about work energy theorem here, because it is the electric force which is doing work, and that work is providing kinetic energy to the particle, right? So it is moving in the y direction at this instant, but whatever kinetic energy it has gained is because of the work of electric field. So what are we going to write, students? So we will write work done by electric field is equals to K final minus K initial. Now what is the electric force? So it is QE, and what is the displacement along the electric field? It is going to be L by 2, right? It's only the displacement along the x-axis, and this is going to be half mv final square minus 0, 2 and 2 cancels out. So this is going to give me QEL over m, right? So the correct answer here clearly is option B, my dear students, right? So they were asking about the speed, even though it's in the y direction, but that's because it's bound to move along the circular arc. Tension will not do any work. Why tension will not do any work? Because tension at every instant is perpendicular to the instantaneous displacement. So it's only the work of the electric field, right? Easy. Copy this down, then we move forward. All right, students. So the next question is from 24 January shift 2. A small charge conducting sphere is placed in contact with an identical sphere. Okay, so these are two identical spheres. They had a combined charge of this, and since they are removed and they are identical, they will equally divide the charge. So it's going to be 2 into 10 raised to the power minus 8 and 2 into 10 raised to the power minus 8. If they would have had different sizes, then charges would have divided in the ratio of their radii, right? But that is not the case here, since they are identical, so we don't need to worry about the ratio, and it's going to equally divide. Now they exert a force of this much, and they are talking about the distance. Okay, one more thing which I was looking for is this word small, right? So this word small has a big role to play in solving this, because now we can apply Coulomb's law, and we can straight away write F is equals to K Q1 Q2 over R square. Can't get easier than this, my dear students. So F is given to be 9 into 10 raised to the power minus 3. The value of K is 9 into 10 raised to the power 9, and Q1 Q2 product I can straight away write as 4 into 10 raised to the power minus 16, and R square is what I have to calculate. So 9 and 9 factor cancels out, and R square turns out to be 4 into 10 raised to the power 9, and this is going to be plus 3, so it's 12 minus 16, so 10 raised to the power minus 4, and if we square root on both sides, so R turns out to be 2 into 10 raised to the power minus 2 meter, and convert that to centimeter. Hence the correct answer is option B. I think one of the easiest question you have ever got in JEE Mains exam, right? All right, so the next question. This is from 24 January shift 2. In the first configuration shown in figure, 4 identical charges are placed at the corners, right? And then they've changed the configuration to the second one, where the charges are brought to the midpoints of the edges, right? Okay. And we have to calculate the difference of potential energy in configuration 2 and configuration 1. Thankfully, these are point charges, so of course we are going to use the formula for potential energy, that is K Q1 Q2 over R, and not R square, my dear students. So what is the initial potential energy? So you are going to get 4 terms of K Q naught square by A because of these 4 combinations, right, along the sides, and then 2 along the diagonal. So it's going to be 2 K Q naught square over root 2A. So this is the initial potential energy which you can easily understand. Now final potential energy, my dear students. So now it is going to be like a square like this, and this side length is going to be a by root 2, of course, right? A by 2, so hypotenuse is going to be a by root 2. So 4 terms, now you are going to have kq naught square divided by a by root 2, and 2 terms are going to be the diagonals of this smaller square, which is going to be equal to a. So 2 terms are going to be like this, 2kq naught square divided by a, my dear students. Now you have to calculate delta u, that is u final minus u initial. So from this term we have to subtract this term. So this minus this is going to give me minus 2kq naught square over a, and this will become 4 root 2, and this is like 2 by root 2. So I can write this as 4 root 2 kq naught square by a, and this can be written as minus root 2 kq naught square over a. So 4 root 2 minus root 2 is going to be 3 root 2, right? So this is going to be 3 root 2, and if I take the term of kq naught square by a common, so this will become 3 root 2 minus 2, right? So easy, right? No problem whatsoever. Answer should be option D, right students? Just you had to write the potential energy. How many terms did you have? 6 terms. Why? Because the general term is how many combinations can you make of 2 when you have n terms? So answer is nc2, that is n minus 1 by 2. So since there were like 4 charges, you had 4 into 3, 12 upon 2, 6 terms in total. 1, 2, 3, 4, 5, 6. Right? Easy potential energy formula you do understand. Copy this down, then we move forward. Right students? So the next question is from 24th January shift 1. A square loop of side 1 meter is held normally in front of a point charge. The flux of the electric flux through the shaded region. Okay, so we can see a square side and we are talking about the shaded region. Okay, so let's understand this. That if there is a charge q and it is surrounded by a cube, we understand through a cube the flux is going to be q by epsilon naught, right students? Because it's a cube, it's like enclosing the charge, so using Gauss theorem it's going to be q by epsilon naught. So through one face, let's say this is phi, is going to be q by 6 epsilon naught. Why students? Because one cube can be taken as 6 faces, so through each face it's going to equally divide. That is what we have discussed in our theory classes as well. So it's going to be q by 6 epsilon naught through one face, that is through this. Now they are talking about how much is through the shaded region. So let's call this 1. Okay, what we can do here is, let me show it to you like this. Let's divide this. Let's draw these as well. Okay, so if I draw these as well, my dear students, so I can write this as, let's say 1, this is let's say 2, this is 3, this is 4, this is 5, 6. Okay, so what am I doing here? I am just dividing this in 8 parts, right? 6, 7 and 8. So what I have done is equally I have divided this in 8 parts, and out of these 8, this 1, 2 and 3 is not shaded. So out of these 8, 5 are shaded. So the flux that we are talking about here is going to be how much, my dear students? So phi dash, let's call it phi dash, is 5 parts out of 8 of what? Q by 6 epsilon naught. So this gives me 5 by 48 Q by epsilon naught. Now the value of Q is given to be 1 coulomb, my dear students. So this becomes 5 by 48 epsilon naught. This was a numerical type problem. We had to fill in the value of P, and the value of P turns out to be 48, my dear students. Very easy, no problem whatsoever. It's only about you maintain your temperament, and you do understand that you only have to worry about how it's dividing. Since it is symmetrical, so it is not a problem, right? Okay students, so the next question is 23rd January shift 2. 2 charges plus 7 microcoulomb and minus 4 microcoulomb are placed at this and this coordinate. Okay, the electrostatic potential energy, very easy. All you have to do is just do k q1 q2 over r. Now, what is the value of K, students? 9 into 10 raised to the power 9. What is the value of Q1? It's 7 into 10 raised to the power minus 6. What is the value of Q2? It's minus 4 into 10 raised to the power minus 6. And what is the value of R? So it's 7 and minus 7. So the gap between them becomes 14. And centimeter has to be converted to meter, my dear students. Don't forget, the value of charge has to be substituted with sign, and hence the potential energy is only going to be negative, because these are unlike charges. But unfortunately all the options are negative, so this time you cannot reject any of the options. Okay, so this is like 14, so this will cancel 2 times and this will cancel 2 times again. So it's going to be minus 18 into 10 raised to the power 9 plus 2 11, 11 minus 12 is like minus 1, so it's going to be minus 1.8 joule. Very simple, the correct answer is going to be option A, my dear students. Right, so the next question. Next question is 23rd January shift 2, 2-point charges constituting an electric dipole 9 and minus 9 in a uniform electric field. The work done in rotating it from the equilibrium through 180. Again, a very similar kind of question. Theta initial is like 0, theta final is like 180. So work done is going to be U final minus U initial. So it's going to be minus PE cos theta final minus cos theta initial. Alright students, very easy. So cos 180 minus cos 0. So cos 180 is going to be minus 1, minus 1, minus 2, minus minus will become plus. So it's going to be 2PE. So value of P is now charge into separation. So it's like 4 into 10 raised to the power minus 6. What about the separation, students? So it's like 18 centimeters. So let's convert that to meter as well. 18 into 10 raised to the power minus 2. So this is like P. And what about E? So E is given to be 10 raised to the power 4 in SI unit. So this is going to be 2 times 4, 8. And this is going to be 8 times 18. Okay. So 8 times 18 is going to be 144. So this is like 144 into 10 raised to the power minus 8 and plus 4. So it's going to be like minus 4 joule. So we can write this as 14.4 into 10 raised to the power minus 3 joule, or it can be written as 14.4 millijoule. So the correct answer is going to be option B, my dear student, right? Copy this down, then we move forward. All right. Next question is 23rd January shift 1. A point particle of charge Q, okay, is placed at point P, and there is electric dipole 1 and electric dipole 2. So for dipole 1 this is like an axial point, and for dipole 2 this is like an equatorial point. Okay, that's even what they have given us. The dipoles are made of opposite charges separated by a distance 2a as usual. For the charge particle at P not to experience any net force, which of the following correctly describes the situation? Okay, so we do understand that this dipole moment direction is to the left, so it will create a force to the left as well. I can also write electric field because it is the same charge, so that means it's a neutral point. So electric field of this dipole, and now this dipole moment is to the left, so at equatorial point it will create an electric field to the right. So this is a neutral point, that means both the electric field should be equal and opposite. One thing, we have to calculate the ratio of A by R, and if we look at the options, A by R is given to be greater than 1. That means this dipole size is even greater than R. Then this makes this question incorrect in a way, because in that case you won't expect a neutral point, right? So that can be a controversy. So in that case it should be given as a bonus, but let's assume that just by using this, what answer do we get? One more thing, students, one more thing, that it is not to be considered as a point dipole, so we will use the expression for general field of dipole, right? So for one it is like equatorial point, and the other it is like going to be an axial point. So let's equate the fields. Now, not for a point dipole but for a general dipole, the electric field at axial point is like 2 kp r over r square minus a square whole square, while at equatorial point it is like kp by r square plus a square raised to the power 3 by 2, my dear students. I hope you know that. So Kp and Kp factor cancels out from both sides. So this becomes what? This becomes 2 into r square plus a square raised to the power 3 by 2. In fact, there is an r as well. So it's going to be like 2r, okay, and this is going to be r square minus a square whole square, right? So let's divide by r raised to the power 4 on both sides just to create the term of a by r. Let's do that. Okay, so I'm dividing by what? I'm dividing by, or let's say I'm taking out the r square term common. If I take the r square term common, student, since this is power 3 by 2, this will become r cube. And what are we left with? 1 plus a square by r square raised to the power 3 by 2. And if I take r square common here, this becomes r4, and this is going to be 1 minus a square by r square whole square. Now this r4 and this r4 cancels out. Let's write this concerned term as x. That's what we are looking for. We are calculating the value of a by r. So this is going to be x square raised to the power 2. So we can't solve this equation because this is like power 3 by 2. Even if we try to write this as 1 plus x and 1 minus x. So what we can then do, since we have the options, we can plug in the values of different options and try. So let's try the fourth option, where we are wanting this term 1 minus x square whole square over 1 plus x square raised to the power 3 by 2, because that's what's given as the answer. So let's just check that. Okay, so this ratio has to be equal to 2, right? So let's try the value of x as 3. Okay, so what does this become, students? 1 minus 3 square power 2, and this becomes 1 plus 3 square power 3 by 2. Let's see if this value turns out to be close to 2. Okay, so this is going to be 1 minus 9, that is minus 8, but squaring that will become 64, and this will be 10 raised to the power 3 by 2. So 10, first we'll do square root, that's going to be root 10, and then cubing that will be like 10 root 10. So when you will solve this value, this will approximately be turning out to be 2. Hence, the value that is satisfying this mathematical equation is a by r is approximately equal to 3. But this question is not exactly correct. But still, if we have to choose the best answer here, then the correct answer would have been option D, that is a by r is approximately equal to 3. Still copy this down, then we move to the next one. Right, students? So, the next question is from 23rd January shift 1. A positive ion A and a negative ion with this much charges and masses this much. At an instant, the ions are separated by a certain distance. At that instant, the ratio of the magnitude, so we don't have to worry about the sign, just the ratio of the magnitude of electric force and gravitational force. Can't get easier than this. Of course, this ratio will be governed by what? K Q1 Q2 divided by G M1 M2, because 1 over r square term will cancel out, so no worries about that. The value of K is going to be 9 into 10 raised to the power 9. The value of Q1 is like 6.67 into 10 raised to the power minus 19, and value of Q2 is like 9.6 into 10 raised to the power minus 10. Right, students? What about the masses? So first value of G is 6.67 into 10 raised to the power minus 11. The masses are like 19.2. This is just putting in the values and nothing else. And this is going to be 9 into 10 raised to the power minus 27. So even the data looks very easy to handle. 6.67 and 6.67 will cancel out. 9.6 will cancel out with 19.2 two times. And this 9 and 9 will also cancel out. So what are we left with, students? We are left with a 2 in the denominator, don't forget that. And the power of 10 is going to be 9 minus 19 minus 10, and this is going to be plus 11, right? Plus 11, and this is going to be plus 54, 27 and 27, right? So this is going to be minus 10 and minus 10, so it's like minus 20, and this is like plus 65. So 65 minus 20 is like 45. So it's like 0.5 into 10 raised to the power 45. That's what they have given us. So that means the value of P is 0.5, but they have asked us to fill in the integral value of 10P. So if we do 10P, we will get 10 into 0.5, that is 5, right? Very easy, no problem whatsoever. I will wait, you copy down, then we move forward. Right, students? Next question. Okay, so this is from 22nd January shift 2. For a short dipole placed at origin, the dipole moment is along the x-axis, as we may see. If electric potential and field at A are V0 and E0, okay, then the correct combination of electric potential and field at B. So B now becomes the equatorial point. At equatorial point, we do understand that potential is always 0. So we will only choose the options which have V0. In fact, that is only in the option B. So we already know the answer, that it's going to be B, because none of the other options has potential 0, right, students? So that is a very easy question now, therefore. But still, let's do the electric field thing. So electric field at axial point, you do understand, is 2 kp by r cube. But at equatorial point, the direction is opposite to P and the strength is kp by r cube. It's a point dipole, it's a short dipole. But this distance is not r now, this distance has become 2r. So it's going to be like kp by 2r whole cube. So that is like kp by 8r cube. So if you compare, this has a 2 in the numerator and this has an 8 in the denominator. That means this term is 1 by 16th time of this term. And hence, option B now makes complete sense, that V is 0 and E is going to be E0 by 16, my dear students, right? Copy this down, then we move forward. Right, so the next question is 22nd January shift 1. An electron is made to enter symmetrically between two parallel plates. All right, so there are like two parallel plates. Let's say one of the plates is positively charged and the other plate is like negatively charged, right? And each of these has a length of 10 centimeter or 0.1. So far so good. The electron, there is an electron, of course it is projected. So we have seen a similar kind of situation in NCERT problem as well, and it will divert like this. So its x velocity will never change and it will have a y velocity now. So in NCERT they have asked the y displacement that it will suffer. But right now they have given us the horizontal component of velocity, they have given us the magnitude of electric field, and they are asking us the vertical component of velocity. So that's the question. Let's say t is equals to 0, it starts. We do apply the concept of motion here, that x and y are separate from each other. One by one we will talk about the two directions. So let's talk about the x direction first. We will straight away apply s is equals to ut plus half at square. That is the second equation of motion. But there is no acceleration in the x direction, so very easy. So this length is L, velocity in x direction is given. This will give us the time. So the time for which the electron will be available between the plates and hence experiencing electric field. So what is the length, students? 0.1. What is the velocity? 10 raised to the power 6. So the time that it's going to spend between the plates, right, students? The time that it's going to spend is going to be 10 raised to the power minus 7 seconds. So 0.1 divided by 10 raised to the power 6 is going to be 10 raised to the power minus 7 seconds. Okay, now let's calculate the acceleration in the y direction, and that's going to be like QE by m. So the value of Q is, why QE by m, students? Because force is QE and divided by m. So Q is 1.6 into 10 raised to the power minus 19, but of course, and the value of E, be very careful, is 9.1 volt per centimeter. So per meter, it's going to be 9.1 into 100. So don't forget to convert it into SI unit. That is a common mistake that people made. Okay, so QE by M. So the mass, again calculation becomes very easy now, because 9.1 and 9.1 will cancel out, and this acceleration turns out to be 1.6 into 10 raised to the power. This is going to be like minus, so this is going to be like plus 31. So 31 and 2 is 33, and from 33 if we subtract 19, right, so we are going to get 14, is it? Yeah, 10 raised to the power 14 meter per second square. So we have acceleration, we have the time. In y direction, we will now apply v equals to uy plus ayt. Now uy is 0, my dear students. There is no velocity in the y direction initially. What is the acceleration? So acceleration is 1.6 into 10 raised to the power 14. Very easy, no problem whatsoever. And t is 10 raised to the power minus 7. So this turns out to be 1.6 into 10 raised to the power 7, right? Which you can also write as 16 into 10 raised to the power 6, since none of the options were matching. So I rewrote this as 16 into 10 raised to the power 6, which completely makes sense. Option C is correct therefore, right? So what did I do? Independently, I treated x direction and y direction, which you have been doing throughout your class 11, so shouldn't be a problem. All right, students. So the next question. Next question is 22nd January. In fact, I think this is the last question that is available of electrostatics from January attempt. Capacitance we are going to take separately in the next video. Okay. So 22nd January, shift 1, a line charge of length a by 2. So this is a line charge, a small line charge. So therefore, its total charge is going to be lambda into a by 2. Since they have given us the charge density is lambda and its total length is a by 2. Okay. Then the total electric flux through all the faces of the cube will be. Okay, students. So this rod is like exactly symmetrically placed at the edge. So therefore, if you look at its side view, you would understand that this is arranged like this. Okay, so this rod is like right drilled at the edge. That means the charge that is enclosed is not going to be the whole charge, but only 1/4 of it, right? So if this charge is q, the enclosed charge inside the cube is only going to be q by 4, my dear students, and hence flux is only going to be affected by this enclosed charge. So it is going to be q by 4 epsilon naught. Now what is the value of q? So it's lambda a by 2. So this becomes lambda a by 8 epsilon naught, my dear students. That's what they are asking, the total flux of all the faces. I think the correct answer is option D, and so should you. Alright, students, so I hope these were very easy questions. I felt that January attempt, in fact this is a normal thing that JEE is doing. January attempt questions are normally very easy, on easy side as compared to the April attempt. So you make most of the January attempt. Do try these questions. Do let me know if you did not understand any particular solution or you thought I rushed up with the solution. But my idea of doing this is just to give you a hint if you faltered, if you made a mistake somewhere. But you are only going to watch these videos if you have tried the questions yourself first. Only then these would be beneficial for you. Right, students? So thank you so much for your time. I hope you're working hard, and we'll keep coming up with such good content which can help you ace your exam. But that's all for this one, students. Bye-bye. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.